Okay, there's two kinds of right triangles that we are going to become very familiar with. And one of them comes from a square. So let's do this. You guys, you have three squares on your screen. This square is a 1 by 1. This square is 2 by 2. And this square is 3 by 3. Now, if you have a square that's 1 by 1, all the sides are the same, all the angles are the same, they're all 90-degree angles. I want you to find the diagonal, how far it is from corner to corner. And this is going to create the first special right triangle. So in a square, if they all have 90-degree angles, you're going to create a right triangle. And this is the right triangle we're looking at right here. It's just half of the square. So that's going to be a 45. That's one, that's one. Here's the 45. 45, 45, 90. And then in this square, if we just look at half of it, it's going to be a 45, 45, 90. So they're going to be similar triangles. They are the exact same shape. They are just going to be different sizes. And this third triangle, this is going to be a 45, 45, 90, and then it's 3 and 3. So here's what we need to do. Find the diagonal. Find the hypotenuse. And after you've found the third one, there's a pattern that hopefully we pick up on that will save us from ever doing a calculation again on a 45, 45, 90 triangle. So push pause, use the Pythagorean Theorem, see if you can find the hypotenuse, and then push play. Okay, on the first one, let's use the Pythagorean Theorem. So let's use a squared plus b squared is going to be c squared. And this diagonal is always going to be my c. So I'm going to go 1 squared plus 1 squared equals c squared. 2 equals c squared. And then the last move, I need to undo the square. So I'm going to square root this, square root this. So this diagonal is going to be square root of 2 long. Okay, now this next one, oh whoops. The next one is going to be, I'm out of room to calculate stuff, so let me insert a page. Okay, so if I've got this, if it's 2 by 2 and it's 45, 45, 90, I'm going to go 2 squared plus 2 squared equals c squared. So 8 equals c squared, square root, square root. But 8 has some squares in it. 8 is the same as 2 times 2 times 2. So it's the square root of 2 cubed. So it is going to be 2 square roots of 2. So the hypotenuse is going to be 2 square roots of 2. And then if I have a triangle that is 3 by 3, I'm going to go 3 squared plus 3 squared equals c squared. So that's a 9 and a 9. 18 equals c squared. If I square root, 18's got some squares in. Let's pull those out. 18 is the same as 2 times 9, and a 9 is a 3 and a 3. So it is 3 squared times 2. And if I pull the squares out, I'm going to get 3 square roots of 2. So in a 45, 45, 90, if my legs are 3, my hypotenuse is 3 square roots of 2. If my legs are 2, my hypotenuse is 2 square roots of 2. And then when my legs were 1 by 1, my hypotenuse was just 1 square root of 2. And that pattern holds true for any 45, 45, 90. Any triangle that is half of a square. So there's going to be 2 types. So let's label this. Let's cut the diagonal and let's label it 45, 45. So if you ever come across a 45, 45, 90, if they give you this length right here, you can fill out every other side. So you know that because these are the same angle, these are going to be the same side. So it's kind of an isosceles triangle. So this is going to be x, this is going to be x, they're going to be x all the way around, and this right here is going to be x square roots of 2. So to find the hypotenuse, you take whatever the side is and you times it by square root of 2. So type 1 is if you know, if you have the legs. Type 2 is if you have C, or if you have the hypotenuse. So if I have the diagonal right here, if they tell me this is x, and this is a 45, 45, 90, and you are asked to work backwards and come up with the legs, you're just going to do the opposite. You're going to take whatever the hypotenuse is, and you are going to divide it by square root of 2. And this leg is going to be the exact same thing. It's going to be x divided by square root of 2. So going forward, you times the legs by square root of 2 to get the hypotenuse, but if they give you the hypotenuse, you got to divide by square root of 2, and then we can't have a square root on the bottom, so we're going to times the bottom by square root of 2, we're going to times the top by square root of 2, and we should have x square roots of 2 over 2. So let's use that and see if we can solve these 4 problems right here that deal with 45, 45, 90 degree triangles. So push pause, see if you can power through them, and then push play and we'll review. Okay, this first one, they give you 8, so it's going to be 8, 8, 8 all the way around. So you can determine that the value of x is going to be 8, and then they want the value of y, and without doing any Pythagorean theorem, it's going to be 8 square roots of 2. Okay, the second one, the 45, is what it's got to catch your eye. If you ever see a 45, 45, 90, you got to recognize, well, that's half of a square. And this time they've given me the diagonal, so it's like the type 2. So to go from the diagonal to the legs, you got to take the diagonal, 4 square roots of 2, and you got to divide it by square root of 2. And the square root of 2 on top and the square root of 2 on bottom are going to divide out and give you 1, so it's just going to be 4 times 1. So it's going to be 4 all the way around that square. X is going to be 4. Okay, the third one, the 45, is the hint that it's half of a square. So if that's 15, they're all going to be 15. So y is going to be 15. And then x, the diagonal, is just going to be, the hypotenuse is going to be whatever the leg is times the square root of 2. Okay, now the last problem, you kind of got to draw a picture of what they're describing. So the diagonal of a square is 8 inches. Find the area. So draw a picture, and they're telling you it's a square, but the diagonal is 8. So the area is just going to be side squared, or it's going to be base times height. So I've got to figure out the sides, and if it is 8, it's the type 2, I'm going to take 8 and I'm going to divide it by square root of 2, times the bottom by square root of 2, times the top by square root of 2. So it's going to be 8 square roots of 2 over 2. And the 8 and the 2, 8 divided by 2 is 4, so it's really 4 square roots of 2. So each side around this square is 4 square roots of 2. The area is going to be 4 square roots of 2 times 4 square roots of 2. So it's going to be 16. And the square root of 2 times square root of 2 is going to give you square root of 4. Square root of 4 is 2, and 2 times 16 is 32. So the area is going to be 32 inches squared. Okay, your second type of special triangle comes from an equilateral triangle. So in the equilateral triangle, each of the three sides are congruent, and each of the three angles are congruent. So if we get a 60, 60, 60, this one right here, this triangle is 2 by 2 by 2. This triangle is 4 by 4 by 4. Okay, and we're going to ask you to find the altitude. The altitude is the height of the triangle. So if you go from a vertex to the base and create a 90-degree, that is the altitude. That's the height of the triangle. So we want to know how tall these triangles are. So we're going to create a 90-degree triangle. So we're going to cut this equilateral into two halves. There's one half. This is 60. And this angle up here is going to get cut in half, and it's going to be a 30, 60, 90. So 30, 60, 90 is the second type of triangle that you got to recognize, and we can do a lot of work on it without any calculations if you just find the pattern and memorize it. So the hypotenuse is 2. This leg is going to be 1, because this is going to be cut in half. That piece is going to be 1, that piece is going to be 1. And the question is, how tall is it? So again, we're going to use Pythagorean Theorem the first couple times till we find the pattern, and then we will never have to calculate again. So a squared plus b squared is c squared. This one is my c. So we're going to go 1 squared plus x squared equals c squared. C is 2, I guess, so it's going to equal 2 squared. So 1 plus x squared equals 4. X squared equals 3. And then undo the square root this, square root this. X is going to be square root of 3. So the altitude of this triangle is the square root of 3. Okay, now the second one. I'm going to erase this stuff. So these triangles are similar. They're the exact same shape. They're just different size. Okay, this triangle I'm going to look at right here. I'm going to look at this half. So that's a 30, that's a 60, that's a 90. Let's say this is 4, this is 2, and the question is, how tall is it? So again, it's going to be x squared plus 2 squared equals 4 squared. So x squared plus 4 equals 16. X squared equals, if I minus 4x squared is going to be 12. And then undo the square root. And 12 has a 4 and a 3, 2 and a 2. So 12 is 2 squared times 3. And so it is going to, at the end of the day, it is going to be 2 square roots of 3. So let's see if we can figure out the pattern. This was 1 square root of 3. This one is 2 square roots of 3. Let's do one more. So this one, 1, 2, 3, 4, 5. So this is a 6 by 6 by 6 equilateral. If I find the height, if I kind of cut this in half, it's going to make a 30, and that's going to make a 30. So we're looking at this triangle right here. That's a 30, that's a 60, that's a 90. This is going to be a 3, this is a 6, and how tall is it? So let's go x squared plus 3 squared equals 6 squared. X squared plus 9 equals 36. Minus 9, minus 9. Alright, so x squared equals, what's 36 take away 9? 27. Number 17. No, it's 27. Alright. Now let's undo the square. Square root this. And then x is going to equal square root of 27. But 27 probably has some squares in it. That's 9 times 3. That's 3 times 3. So the square root of 27 is the same thing as the square root of 3 cubed. So a 3 is going to come out, and a 3 is going to stay in. 3 square roots of 3 is going to be how tall that is, the altitude. So the pattern on a 6 by 6, it's 3 square roots of 3. This one was 2 square roots of 3, and this one was 1 square root of 3. So it's always going to be the square root of 3, and it is always going to be half of your sides. So if your sides are 6, half of it's going to be 3 and a 3. And then we've got 3 square roots of 3 tall. So let's look, this one has kind of 3 types. Type 1, if they give you this, if they give you the sides. So if the sides are all x, and you got to figure out all the pieces, these pieces are going to be whatever x is cut in half. And then the height is going to be this short piece times the square root of 3. So it's going to be whatever x was, cut it in half, and then times it by square root of 3. Okay, type 2. So type 1 is if you have a side. Okay, type 2, if you have half the side. So if you have this right here is x. If you know this is x, you know this is also x. You know this is going to be 2x. And then you know the altitude is going to be whatever the short one is times the square root of 3. So those two are the easiest to work with. This third type is kind of hard. If you have the height, so if you have the altitude, so the altitude, if they give you this, that it's x tall, so now we got to work backwards. If it's x tall, we got to take that and we got to divide it by square root of 3. And then this is going to be the same. It's going to be x divided by square root of 3, and then the other side is going to be that doubled. So it's going to be 2 times x divided by square root of 3. And then we can't have a square root of 3 on the bottom, so we're going to times the bottom by square root of 3. We're going to times the top by square root of 3, so it's going to be x square root of 3 over 3. And that doubled is just going to be 2x square roots of 3 over 3. So those are the two special triangles. If you memorize the patterns, you never have to do any calculations with them, and we are going to be doing probably the next few weeks with these types of triangles. So here you go. Here's 4 problems. See if you can work them out without doing any calculations, and then so pause it, try them out, and then push play to review them. Okay, number 4, if they give you 16, so here's your 60, 60, these are each 30, 16, all the sides are going to be 16. So these two little guys are going to be 8. So x is going to be 8, and y is going to be whatever this is times the square root of 3. Okay, now number 1. Here is your 30. So the 30, 60 is the hint that it is half of an equilateral. So I always draw the other half. If you draw the other half, you'll never go wrong. And the other half is always flipped across the 30-degree angle. Okay, so now this, you're looking at the little guy, so this must also be 4 square roots of 3. So 4 square roots of 3 and 4 square roots of 3. Each side is going to be 8 square roots of 3. It's going to be double 4 square roots of 3. So y is going to be 8 square roots of 3. And then x, the height of it is going to be 4 square roots of 3 times the square root of 3, which is going to be 4 square roots of 9, which is, the square root of 9 is 3, 3 times 4, x is going to be 12. Number 3, so let's draw the other half of the triangle. So 30, 60, 90, the other half looks like this. And each of the 3 sides is going to be 6 square roots of 3. And if I cut that in half, x is going to be 3 square roots of 3. And then the height, I'm going to take 3 square roots of 3 and I'm going to times it by a square root of 3, so it's going to be 3 square roots of 9. Square root of 9 is 3. It is going to be 9. Okay, number 10. We're going to have to draw a picture and see what they're describing. So number 10. Man, that's bad. Alright. The altitude of an equilateral is 12. So an equilateral, all 3 sides are congruent. The height of it's going to be 12. What's the perimeter? So the perimeter is going to be each of these 3 sides added together. So if they've given me the altitude, this is like type 3. I'm going to go from the altitude to these little guys cut in half, and it's going to be 12 divided by square root of 3. And then I'm going to times the bottom and the top by square root of 3. So it's going to be 12 square roots of 3 over 3. And then 12 divided by 3 is going to be 4 square roots of 3. So each of these 3 sides is 4 square roots of 3. If I add them all together, it's going to be 4 square roots of 3 times 3. Or 4 square roots of 3 plus 4 square roots of 3 plus 4 square roots of 3. And it's going to end up, either way, you're going to end up with 12 square roots of 3. So these are the 2 types of triangles. One comes from a square, one comes from an equilateral. When you come across a 45, 45, 90, or 30, 60, 90, if you remember these patterns, you never have to do any calculations. It'll save you a lot of time and work. And that is it.